In this video, the learning target we're going to look at is I can graph a system of inequalities in two variables. So what we're going to be doing is we're going to be given two inequalities and we're going to graph both of them. And we're going to shade in the region of the graph that contains the points on the graph that make both inequalities true. So to be a solution to a system of inequalities means that you're an ordered pair, a point, x, y, that makes not just one of these true, but makes both of them true. Okay, so if we look at number one here, I have y is less than negative x plus 1 squared plus 7. You'll notice this is in vertex form, so the shifts tell me where the vertex is. I go left 1, up 7. Left 1, up 7, that's the vertex point. Once I have the vertex on my graph, I then use the stretch. I have a negative 1, so I go over 1, down 1, over 1, down 1, over 2, down 4. And then mirror that to the other side. Okay. Once I have the points of my parabola, I then see that it's just a less than sign. Remember that greater than or less than, if there's no equal to, we use a dotted line. Okay, the dotted line is indicating that the line itself does not include solutions. So there are no solutions to this inequality on this line. Okay. Now, I'm going to leave that graph for a second. I'm going to graph the second one. So this one says y is less than or equal to negative 1/2 x plus 3. I'm going to go ahead and graph this guy. So plus 3 takes me left 3. And then I have negative 1.5 as my slope. So I go over 1, down 1/2, and over 2, down 2. This time it's equal to, so it's a solid line. So I draw a solid line through those points. Okay, remember a solid line means that the points on that line do make this guy true. And then I just need to shade the regions. Now, you'll notice it says y is less than or equal to this equation. So if you remember, if I put my pen on the vertex of that equation, so I'm looking at the top guy, so I'm on the dotted line equation, and it says less than. Well, less than is below, right? You're under it. You're less than it. You're below it. So if I make a jump down, notice I land on the inside of the parabola. So I'm going to lightly shade, okay, emphasis on lightly here. I'm going to lightly shade the inside of the dotted parabola, okay? Then I go to the second one, so I put my pen on the second vertex, and it says that one is less than or equal to the equation. So less than again means I jump down. I'm less than and I'm beneath it, so I jump down and I land inside that parabola. So I'm going to lightly shade the inside of that parabola. Okay, and then the solutions to the system are where those shaded regions overlap. So you'll notice I want to be underneath the solid line and underneath the dotted line so they overlap in this region here. So I'm going to darken that region in. Okay, so my solutions to this system of inequalities falls in this darkened region. Okay, so that represents the solution. So if I were to ask you, let's say, does this point, would that make both inequalities true? The answer is yes, because it falls in the solution region. If I said the point over here, the answer is no. It makes one of the inequalities true, but it doesn't make them both true. Same thing over here. If I took this point, the answer is no. It makes the top one true, but it doesn't make the bottom one true. If I picked a point on this solid line, because the line is solid and it's in the shaded region, that's going to be a yes. If I pick the one on the dotted line, that's going to be a no because it doesn't make the dotted line one true. Okay, so it's got to be in the shaded region and on the solid line of the shaded region in order to be a solution. All right, let's go ahead and look at the second example. So I have y is greater than or equal to x squared minus 8. So I've been shifted down 8 and I have a stretch of 1. So it's over 1, up 1, and over 2, up 4. This time it's equal to, so we're going to put a solid line through those points. It also says y is greater than or equal to the equation. So if you put your pen on the vertex and you're greater than it, that means you're bigger than it, you're above it. So you go up, you make that jump up, you land on the inside again. So you're going to lightly shade the inside of that parabola. Okay. Then I look at the second guy. It says y is less than -2 times x plus 1 squared plus 4. I've been shifted left 1, up 4. So I go left 1, up 1, 2, 3, 4. Then I have a stretch of -2. So over 1, down 2, over 2, down 8. And then that gets mirrored to the other side. This time it's just less than. So remember, greater than or less than is just a dotted line. So we put the dotted line through our points. Oops, not too wide. All right. Once I have the line graph, then I need to do the shading. It says y is less than the equation. So if I'm on the line and I go less than it, that means I'm going to jump down. And so I'm going to shade underneath that equation. And remember, I'm looking for where those shaded regions overlap. So if I'm shading up and I'm shading down, the overlap occurs in the middle here. Okay, so this shaded region there represents the solutions. Okay, so once again, that region is your solution set. So if I were to say, is this point a solution? You would say yes, because it's in the shaded region. If I said, is this point a solution? You would say no, because it's not in the overlapped area. If I'm on the dotted line, the answer is no, because it doesn't make that equation true, because it's on a dotted line, okay? Dotted line means not a solution. But if I fall on the solid line, next to the shaded region, that is going to be a solution. That will make both of them true. Okay, so solid line is a solution. Now you gotta be a little careful with that. Like if I fell on the solid line over here, notice that that's not a part of the shaded region, so that would not be a solution. Okay, you have to be on the solid line and a part of the double shaded area to be a solution.